Hello everyone. So we just got some major developments on 3I Atlas, and what we are seeing in this latest observation is genuinely remarkable. The Hubble Space Telescope captured new images in late December 2025, right around New Year's Eve, and what they reveal is unlike anything we have observed before. 3 days ago, the Hubble Space Telescope captured something extraordinary, an image that has reignited one of the most fascinating debates in modern astronomy. The 7th of January, 2026, the clearest view yet of interstellar object 3I Atlas reveals a structure that should not exist according to conventional comet physics. A triple jet configuration, perfectly symmetric, with a dominant feature pointing directly toward the sun, not away from it, as every comet we have ever studied does. Toward it, and when processed using specialized filters designed to reveal hidden structures, the geometry becomes impossible to dismiss as coincidence. Welcome to the universe of AB, where we explore the cutting edge of astrophysical research and the questions that challenge our understanding of what is possible. I am your host, and today we are examining Professor Loeb's latest analysis of 3I Atlas, an interstellar visitor that continues to defy explanation 6 months after its discovery. What you are about to see is not speculation. These are observations from humanity's most powerful space telescope, analyzed by one of the world's leading astrophysicists, revealing anomalies that demand serious scientific attention. Whether these anomalies indicate natural processes we do not yet understand, or something else entirely, is the question at the heart of this investigation. Let's dive in. On the 7th of January 2026, Hubble captured its latest series of observations of 3I Atlas. The raw image shows what appears to be a standard cometary coma, a fuzzy glowing cloud surrounding a bright central nucleus. Nothing unusual at first glance, but astronomer and image analyst Tony Scarato applied a specialized processing technique called the Larson-Cicanina rotational gradient filter. This filter removes the circularly symmetric glow around the nucleus, revealing structures that would otherwise remain hidden beneath the brighter coma. And what emerged stopped researchers in their tracks. A triple jet structure emanating from the nucleus. 3 distinct features separated by equal angles from each other, approximately 120 degrees apart, perfect geometric symmetry. The dominant feature, the one that immediately captures attention, is what astronomers call an anti-tail, a jet extending approximately 400,000 kilometers sunward, nearly the distance from Earth to the Moon, not trailing away from the sun as radiation pressure and solar wind would dictate, but pointing directly toward it. According to Professor Loeb's analysis published on Medium just days ago, this anti-tail is tightly collimated, beam-like in its structure, more than 10 times longer than it is wide. The 2 minor jets are equally puzzling. They are not oriented away from the sun either, as traditional cometary tails would be. Instead, they maintain fixed angular separation from the anti-tail, creating a 3-fold symmetric pattern. This is not the first time Hubble has observed unusual features on 3I Atlas. Previous images from July, November, and December 2025 showed similar structures, but the January 7th image is the clearest, yet the highest resolution, the most detailed view of an anomaly that has persisted throughout 3I Atlas's journey through our solar system. And persistence is key here. A momentary outgassing event could be dismissed as natural variation, a transient burst of activity as the comet rotates and different areas of its surface face the sun. But we are talking about a structure that has remained coherent and sunward pointing across millions of kilometers of space through perihelion passage, and now, as the object recedes from the sun, that is not transient. That is not random. That is sustained, directed behavior. Let's talk about what an anti-tail actually is, because this is where the physics gets interesting. In normal comets, tails form when volatile ices on the nucleus sublimate. Solid ice transitions directly to gas as solar heat increases. This gas, carrying dust particles with it, gets pushed away from the sun by 2 forces: solar radiation pressure acting on the dust and solar wind. the stream of charged particles flowing outward from the sun. The result is a tail that always points away from the sun. Always. This is one of the most fundamental and reliable behaviors in cometary physics. Anti-tails can occur, but they are almost always optical illusions. Projection effects caused by viewing geometry. When we observe a comet from a specific angle, dust particles left behind in the comet's orbital plane can appear to extend toward the sun, even though they are actually part of the tail structure pointing away. It is like looking at a curved line from an angle that makes it appear straight. The phenomenon is not real, it is perspective. But 3I Atlas's anti-tail is not an optical illusion. When Hubble first imaged the object on the 21st of July 2025, the observing angle was only 10 degrees off the sunward direction. Simple trigonometry, accounting for the viewing geometry, revealed that the true elongation of the structure was approximately 5.8 times greater than it appeared in the projected image, making it more than 11 times longer than wide, a highly collimated beam structure. And here is the critical point. Multiple observations at different dates, different distances from the sun, different viewing angles have all confirmed the same feature. If this were a projection effect, it would change appearance dramatically as our viewing angle changed. It would disappear entirely at certain geometries. It has not. According to Loeb's analysis published this week, the anti-tail remained prominent in the January 7th image, despite 3I Atlas now being significantly farther from the sun than during perihelion. The solar heating that drives cometary activity should be decreasing. The jets should be weakening, dispersing, changing orientation as the comet rotates. Instead, we see the same tightly focused sunward jet maintaining its collimation across vast distances. This is anomalous, genuinely, undeniably anomalous. Now we get to what Professor Loeb considers one of the most statistically significant aspects of this entire phenomenon, the rotation axis of 3I Atlas. A paper published in Astronomy and Astrophysics by Sarah Ricard, Licandro, and Alaron documented a wobbling pattern in the anti-tail jet during July and August 2025. This wobble indicated that the jet base is offset by less than 8 degrees from the poles of the object's rotation axis. As 3 Atlas rotates, the jet precesses along a small cone surrounding this axis, like a lighthouse beam sweeping across the sky, but with a very narrow cone angle. Here is where it gets statistically interesting. For this tight collimation to be maintained, for the anti-tail to appear as a coherent beam extending hundreds of thousands of kilometers sunward, the rotation axis must be nearly aligned with the direction of the sun. Loeb's calculations, published in multiple Medium articles analyzing different observation periods, indicate that the rotation axis is aligned to within approximately 6 to 8 degrees of the sunward direction. The probability of this occurring at random, 0.2% to 0.5%, depending on the exact measurement. That is a 1 in 200 to 1 in 500 chance. Now one could argue that rare things happen. A 0.2% probability event is not impossible, but this is not occurring in isolation. The trajectory of 3I Atlas is aligned to within 5 degrees of the ecliptic plane, the flat disk in which the planets orbit the sun. For an interstellar object arriving from random directions in the galaxy, this alignment has a probability of approximately 0.2%. The combination of trajectory alignment and rotation axis alignment, the compound probability, drops to approximately 0.001, 1 in 10,000, and we have not even factored in the other anomalies yet. The arrival timing that brought 3I Atlas close to Mars, Venus, and Jupiter, while being unobservable from Earth at perihelion. The unusually high nickel-to-iron ratio in its gas emissions, resembling industrial alloys rather than natural cometary compositions. The fact that the same sunward jet persisted both before and after perihelion, requiring similar alignment at opposite poles of the rotation axis. Each anomaly individually might be dismissed, rare but natural. But when you stack them, when you calculate the compound probability of all these unlikely geometries and behaviors occurring simultaneously in a single object, you enter territory where dismissal becomes intellectually difficult. Loeb is not claiming definitive evidence of artificial origin. He is pointing out that the statistical improbability demands serious investigation rather than casual dismissal. Let's return to that January 7th Hubble image and examine the triple jet structure in detail. After Larsen-Sechenina filtering, three distinct features emerge: the dominant anti-tail, which we have discussed extensively, and two minor jets positioned at approximately 120 degrees separation from each other and from the anti-tail. Perfect threefold symmetry. In his January 2026 Medium post analyzing Hubble images from November and December, Loeb noted that these minor jets show variability. Their extent changes over the object's 16-hour rotation period, variations of approximately 5,000 kilometers over an 8-hour period. This is consistent with thermal velocity of volatile molecules sublimating from ice pockets on a rotating nucleus. Jets turn on when their source regions rotate into sunlight and turn off when they rotate into shadow. This is normal cometary behavior. Nothing anomalous here, but the anti-tail is different. It is an order of magnitude larger than the minor jets, and it shows no corresponding variability with rotation. It remains coherent and stable across much longer timescales. For this stability to exist, Loeb argues, the anti-tail source must be located very close to the rotational pole, within that 6-degree cone we discussed. If it were located elsewhere on the surface, rotation would cause the jet to sweep through large arcs. The beam would appear and disappear as the source region rotated through day and night. Instead, we see a lighthouse effect. The jet precesses in a tight cone around the rotation axis, which is itself pointed at the sun. From our viewing angle, this appears as a persistent sunward beam, with only slight wobbling. Natural gas dynamics can produce jets from rotating comets. Absolutely. This happens all the time. But having multiple jets in perfect 120-degree symmetry, combined with rotation axis alignment, combined with trajectory alignment, combined with compositional anomalies, combined with unusual mass-to-brightness ratios, the compound probability keeps shrinking. It is important to address the scientific debate surrounding 3I Atlas directly and fairly. NASA held a press conference on the 19th of November 2025, presenting their assessment of 3I Atlas. Their conclusion: it behaves like a regular comet, natural origin, no evidence of artificial construction. This conclusion is based on extensive data, spectroscopic analysis showing water and carbon dioxide ice, cometary coma structure, outgassing rates consistent with solar heating. These are legitimate observations supporting natural origin. But Professor Loeb, in his January 9th Medium article, points out a significant issue with NASA's presentation. The geometric anomalies, the statistical improbabilities we have been discussing, were not mentioned at the press conference. The rotation axis alignment, the trajectory alignment, the compound probability calculations, these were not addressed. Loeb writes, obviously, if one ignores the unexplained anomalies of 3I Atlas, one would conclude that there is nothing surprising about it. The easiest way to argue that we fully understand something is by ignoring what we do not understand about it. This is a methodological criticism, not a personal attack. In science, we are supposed to address all the data, especially the data that does not fit our preferred model. If there is a natural explanation for why an interstellar object would have its rotation axis aligned sunward with 0.2% probability, that explanation should be published and peer-reviewed. If there is a natural mechanism that creates perfect 120-degree jet symmetry while maintaining a 10 times larger collimated anti-tail, that mechanism should be demonstrated through modeling and simulation. Simply stating it is a natural comet without addressing the geometric anomalies is not sufficient scientific rigor. Now, does this mean 3I Atlas is artificial? Not necessarily. Nature can be weird, really weird. Improbable things do happen. But improbable things that happen repeatedly in the same object, creating compound probabilities approaching 1 in 10,000 or worse, deserve investigation proportional to their improbability. That is what Loeb is advocating for, not jumping to conclusions, but proportional investigation. The Galileo project, which Loeb heads, exists specifically for this purpose, to investigate potential technosignatures with proper scientific methodology, not to prove aliens exist, but to look carefully at anomalous data and determine what it actually represents. We should also discuss the SETI observations because they are directly relevant to the artificial hypothesis. Breakthrough. Listen, the most comprehensive search for extraterrestrial intelligence currently operating conducted extensive radio observations of 3I Atlas. Using the Green Bank telescope, the largest single-dish radio telescope in the world, they scanned frequencies from 900 to 1,670 MHz during 3I Atlas's closest approach to Earth on the 19th of December 2025. Their results, published in a preliminary paper this month, detected approximately 470,000 candidate signals initially. After filtering out human-generated radio interference, satellites, and other terrestrial sources, they were left with 0 candidate technosignatures. Detection sensitivity, 0.17 watts, enough to detect a cell phone signal at 3I Atlas's distance. Their conclusion: there is currently no evidence to suggest that interstellar objects are anything other than natural astrophysical objects. This is significant evidence against the artificial hypothesis. If 3I Atlas were a functioning spacecraft or probe, you would expect some form of electromagnetic emissions, communication systems, power generation signatures, navigation systems. Nothing was detected. However, as the Breakthrough Listen team themselves noted, given the small number of such objects known, only 3 to date, and the plausibility of interstellar probes as a technosignature, thorough study is warranted. They are not dismissing investigation. They are saying their radio observations found nothing. But that does not close the book on anomalous behavior in other domains. A non-functioning derelict would not produce radio signals. A light sail pushed by radiation pressure would not need onboard power. The absence of radio signals rules out certain types of artificial origin, but not all conceivable types. So where does this leave us? With an object displaying multiple statistical anomalies in its geometry and trajectory, but no detected artificial signals, natural origin with unusual characteristics remains the most parsimonious explanation, but unusual enough to justify continued close observation and analysis. 3I Atlas is currently in the constellation Cancer, fading as it moves away from the Sun. Current magnitude approximately 13 to 15.6, depending on observing conditions. Opposition occurs on the 22nd of January 2026, when it will be directly opposite the Sun in our sky. Up all night, but faint, very faint. You will need an 8 to 12-inch telescope under dark skies to visually observe it. For astrophotographers, long exposures can still capture the coma and possibly even hints of the jet structures we have been discussing. But the real action comes in March, the 16th of March 2026, closest approach to Jupiter. Distance, 0.358 AU, approximately 53.6 million kilometers. On March 17th, it passes within 30 million kilometers of Eupheme, one of Jupiter's irregular outer moons. Loeb has stated that if 3I Atlas releases daughter objects that enter orbit around Jupiter during this encounter, it would constitute strong evidence for technological origin. That is a testable prediction, a falsifiable hypothesis. If it happens, if we observe smaller objects separating from 3I Atlas and establishing orbits around Jupiter rather than continuing on hyperbolic trajectories, that would be extraordinarily difficult to explain through natural means. If it does not happen, if 3I Atlas simply passes Jupiter and continues outbound with only minor gravitational deflection, that supports natural origin. Either way, we will have more data, more observations, more constraints on what this object is and is not. After Jupiter, the long goodbye begins. Saturn system late 2026, Uranus 2027, Neptune 2028. By the time it reaches the inner Oort cloud around the year 2189, no human alive today will be here to witness it. And by the time it exits the Sun's gravitational influence entirely around the year 10,000, human civilization will have transformed beyond recognition, or ceased to exist, or spread across the galaxy. 3I Atlas will continue its journey through interstellar space, carrying whatever mysteries we could not unlock in the brief months we had to study it. Let's step back and ask the bigger question: why does 3I Atlas matter beyond the immediate fascination of an interstellar visitor? First, it represents our best opportunity yet to study material from another stellar system without building interstellar spacecraft. Every spectrum we capture, every photometric measurement we make, every image we process tells us something about conditions around other stars, the composition, the structure, the behavior under solar heating. All of this informs our models of planetary system formation across the galaxy. Second, it is establishing protocols for how we study rare transient phenomena. Oumuamua caught us off guard. We had just days of useful observation before it was too faint to study. 2I Borisov was better, but its trajectory was not optimal for Earth-based observation. 3I Atlas has been perfect. Discovered early, observed extensively, documented by multiple instruments across multiple wavelengths. Whatever else it is a masterclass in coordinated astronomical observation. Third, and this is where Loeb's work becomes particularly important, it is forcing us to develop better frameworks for evaluating anomalous data. How do we balance the principle that extraordinary claims require extraordinary evidence with the equally important principle that we should not dismiss statistically significant anomalies just because they are uncomfortable? The compound probability calculations Loeb presents are not wild speculation. They are straightforward statistical mechanics. If the geometries and behaviors we observe have probabilities of occurrence at 1 in 10,000 or worse, that is information. That is signal. It might be signal of natural processes we do not fully understand yet. It might be signal of selection bias in our detection methods. It might be signal of something else. But it is signal. It is data demanding explanation. And good science follows the data wherever it leads, even when it leads somewhere uncomfortable. Let me explain why the collimation of the anti-tail is so puzzling from a physics standpoint. When gas vents from a comet nucleus, it expands. The molecules are moving at thermal velocities, typically a few hundred meters per second. As they move away from the nucleus, they spread out. The jet diverges. It gets wider and wider as it extends into space. This is basic gas dynamics. You cannot maintain a tightly focused beam over long distances without some mechanism to confine it. But 3I Atlas's anti-tail is maintaining its collimation over 400,000 kilometers. That is more than 10 times longer than it is wide. For comparison, imagine a laser pointer. The beam stays tight because the light is coherent and focused by optics. But a gas jet from a comet has no optics, no focusing mechanism. It should spread out rapidly, unless there is a magnetic field. If the gas is ionized, if it is carrying charged particles, a magnetic field could confine it, could keep it collimated. But comets do not typically have strong magnetic fields. They do not have the internal structure, the dynamo, the power source to generate fields of that magnitude. So how is 3I Atlas maintaining this collimation? What mechanism is keeping the anti-tail focused over such vast distances? This is one of the central mysteries that has not been adequately addressed by the natural comet hypothesis. The wobbling pattern documented in the Astronomy and Astrophysics paper provides crucial information about the object's structure and dynamics. The anti-tail jet precesses around the rotation axis with a cone angle of less than 8 degrees. This precession is caused by the jet base being slightly offset from the exact rotational pole. As the object rotates every 16 hours, the jet sweeps out a small cone in space. From our viewing angle, this appears as a wobble, but here is what is interesting. The wobble is regular. It is predictable. It follows the rotation period exactly. This tells us that the jet source is fixed to the surface. It is not moving around. It is not migrating. It is locked in place. For a natural comet, this is somewhat unusual. Cometary activity often shifts as different regions of the surface are exposed to sunlight. Active areas can migrate, new vents can open, old ones can close, but the anti-tail source appears to be stable, fixed, unchanging. This could be explained naturally. Perhaps there is a particularly large ice deposit at that location. Perhaps the surface structure channels gas flow in a specific way. But combined with all the other anomalies, it adds another layer of strangeness to an already strange object. Another anomaly that has not received much attention is the mass-to-brightness ratio of 3I Atlas. Based on its brightness and the amount of light it reflects, we can estimate its size. Current estimates put it at around 200 meters in diameter. But based on its trajectory and the gravitational perturbations it experiences, we can estimate its mass. And the mass seems too high for an object of that size. Either 3I Atlas is much denser than a typical comet, or it is much larger than it appears. If it is denser, that suggests a different composition. Less ice, more rock, or perhaps metal. If it is larger than it appears, that suggests it is very dark. absorbing light rather than reflecting it. Either way, the mass-to-brightness ratio is anomalous. It does not fit the profile of a typical comet. This could be explained naturally. Perhaps it is a fragment of a larger body. Perhaps it has an unusual composition due to the conditions in its home star system. But again, it is another anomaly, another data point that does not quite fit. There is also the question of timing. Why are we seeing these interstellar visitors now? Oumuamua in 2017, 2I Borisov in 2019, 3I Atlas in 2025, 3 interstellar objects in less than a decade. Before 2017, we had never confirmed a single one. Is this because our detection capabilities have improved? Are we finally able to see objects that have always been passing through, but we just could not detect them before? Or is there something else going on? Is the rate of interstellar visitors actually increasing? Some researchers have suggested that we might be entering a region of the galaxy with a higher density of interstellar objects, a stream or cloud of debris from some ancient stellar event. Others have suggested that these objects might not be random at all, that they might be part of a coordinated survey, probes sent by an advanced civilization to explore neighboring star systems. If that is the case, if these are probes, then the timing makes sense. They would arrive in clusters. They would be coordinated. They would be part of a mission. But this is speculation. We do not have enough data to say for certain. What we can say is that the timing is interesting, and it raises questions that deserve investigation. The spectroscopic analysis of 3I Atlas has revealed some unusual chemical signatures. As I mentioned earlier, the nickel-to-iron ratio is anomalously high. In natural objects, nickel and iron are almost always found together in roughly equal proportions. But 3I Atlas is showing nickel with very little iron. This suggests either a very unusual formation environment or some kind of processing. There are also unusual abundances of certain organic molecules, complex carbon compounds that are not typically seen in such high concentrations in comets. These could be natural. They could be the result of unique conditions in the star system where 3I Atlas formed. But they are unusual. They are anomalous. They are worth investigating further. The trajectory of 3I Atlas is also worth examining in detail. It entered the solar system from above the ecliptic plane, made a close pass by Mars, then Venus, then Earth, and is now heading toward Jupiter. Each of these close passes provides a gravity assist, a boost in velocity from the planet's gravitational field. This is a technique we use for spacecraft. The Voyager probes used gravity assists to visit multiple planets. New Horizons used a Jupiter gravity assist to reach Pluto. But for a natural object to follow a trajectory that provides multiple gravity assists is unusual. Not impossible, but unusual. The probability of an interstellar object entering the solar system at just the right angle, with just the right velocity, to receive multiple gravity assists from multiple planets is very low. Again, low probability does not mean impossible, but it is another anomaly, another data point that does not quite fit the natural comet hypothesis. The light curve of 3I Atlas, the graph of its brightness over time, shows periodic variations with a period of approximately 16 hours. This is consistent with a rotating object. As it spins, different parts of the surface reflect different amounts of light, causing the brightness to vary. But the variations are very regular, very consistent. The period does not change. The amplitude does not change. For a natural object, you would expect some variation. The rotation period might change slightly due to outgassing torques. The amplitude might change as different regions become active or inactive. But 3I Atlas's light curve is remarkably stable. The rotation is steady. The variations are consistent. This could be explained naturally. Perhaps the object is very uniform. Perhaps the outgassing is symmetric and does not create significant torques. But it is another anomaly. Another data point that is slightly unusual. The outgassing pattern of 3I Atlas is also unusual. Most comets show symmetric outgassing. As they heat up approaching the sun, activity increases. As they cool down moving away from the sun, activity decreases. But 3I Atlas showed asymmetric activity. It was more active after perihelion than before. This is not unheard of. Some comets show delayed outbursts as heat penetrates into the interior and triggers subsurface ice to sublimate. But the degree of asymmetry in 3I Atlas is unusual, and the fact that the anti-tail persisted both before and after perihelion, maintaining the same orientation, is even more unusual. This suggests that whatever is driving the anti-tail is not just solar heating. There is something else going on. Section 16. The features, what we cannot see. One of the frustrating aspects of studying 3I Atlas is that we cannot see its surface in detail. Even with Hubble, the object is too small and too far away to resolve surface features. We can see the coma, we can see the jets, but we cannot see the nucleus itself. This means we are missing crucial information. We do not know what the surface looks like. We do not know if there are craters or smooth areas or unusual structures. All we have are the indirect observations, the light curve, the spectrum, the jet patterns. It is like trying to understand a person by only seeing their shadow. You can learn some things, but you are missing the most important information. If we could see the surface of 3I Atlas, we might be able to answer many of these questions. We might be able to see if there are unusual structures, if there are signs of artificial construction, but we cannot. And by the time we develop the technology to send a probe to intercept an interstellar visitor, 3I Atlas will be long gone. When we compare 3I Atlas to other comets, both from our solar system and the other interstellar visitors, several differences stand out. First, the anti-tail. While some comets show anti-tails, they are usually optical illusions. 3I Atlas's anti-tail appears to be a real physical structure. Second, the triple jet geometry. The perfect 120-degree symmetry is unusual. Most comets show irregular jet patterns. Third, the rotation axis alignment. The fact that the rotation axis is aligned with the Sun to within a few degrees is statistically unusual. Fourth, the composition. The high nickel-to-iron ratio and the unusual organic abundances are different from typical comets. Fifth, the trajectory. The multiple gravity assists and the precise targeting of Jupiter are unusual. Sixth, the mass-to-brightness ratio. The object appears to be either denser or darker than typical comets. Any one of these differences could be explained naturally, but all of them together create a pattern that is difficult to ignore. So how should we approach 3I Atlas from a scientific standpoint? First, we should acknowledge the anomalies. We should not dismiss them or ignore them. They are real, they are measurable, they are statistically significant. Second, we should investigate natural explanations. We should try to understand if there are physical processes we do not yet know about that could explain these anomalies. Third, we should consider alternative explanations. If natural explanations are insufficient, we should be willing to consider other possibilities, including artificial origin. Fourth, we should gather more data. We should continue to observe 3I Atlas. We should watch what happens at the Jupiter encounter. We should look for similar objects in the future. And fifth, we should be honest about what we do not know. We should not claim certainty when we have uncertainty. We should not dismiss possibilities just because they are uncomfortable. This is the scientific method. This is how we make progress, by following the data wherever it leads. As we approach the Jupiter encounter in March 2026, there are several things we should be watching for. First, any changes in the trajectory. If 3I Atlas makes course corrections, that would be strong evidence for propulsion. Second, any changes in the jet patterns. If new jets appear or old ones disappear, that would tell us about the surface activity. Third, any release of daughter objects. If smaller objects separate from 3I Atlas and enter orbit around Jupiter, that would be extraordinary. Fourth, any changes in the rotation. If the rotation period changes or the light curve changes, that would tell us about the object's structure and dynamics. And fifth, any unusual interactions with Jupiter's magnetosphere. If 3I Atlas creates disturbances in Jupiter's magnetic field, that would suggest it has its own magnetic field or is electrically charged. All of these observations will help us understand what 3I Atlas really is, whether it is a natural comet with unusual properties or something else entirely. Let's talk about what it would mean if 3I Atlas is artificial, what it would mean for humanity to discover that we are not alone. First, it would fundamentally change our understanding of our place in the universe. We would no longer be the only intelligence. We would be part of a larger cosmic community. Second, It would raise profound questions about the nature of intelligence and consciousness. If another civilization can build interstellar probes, what does that tell us about the possibilities for our own future? Third, it would challenge many of our assumptions about physics and technology. If 3i Atlas is using propulsion systems we do not understand, what does that tell us about what is possible? Fourth, it would raise questions about contact. If there are other civilizations out there, should we try to communicate with them? What would we say? What would they say to us? And fifth, it would force us to confront our own mortality as a species. If other civilizations have survived long enough to develop interstellar travel, what does that tell us about our own chances of survival? These are not easy questions. They are profound. They are unsettling. But they are questions we need to be asking, because whether 3i Atlas is artificial or not, the fact that we are asking these questions means we are ready to confront the possibility that we are not alone. Now let me present the skeptical view. The reasons why 3i Atlas might be entirely natural, despite all the anomalies. First, we have only studied 3 interstellar objects. Our sample size is tiny. We do not know what the full range of natural variation looks like. Second, comets are complex. They have irregular shapes, uneven surfaces, varying compositions. It is entirely possible that 3i Atlas is just at the extreme end of natural variation. Third, our observations are limited. We cannot see the surface, we cannot measure the mass directly. We are working with incomplete data. Fourth, statistical anomalies happen. A 1 in 10,000 event is rare, but not impossible. If we observe enough objects, we will eventually see rare events. And fifth, the absence of radio signals is significant. If 3i Atlas were an active probe, we would expect to detect some kind of electromagnetic emissions. The fact that we do not suggests it is natural. These are all valid points. They are reasons to be cautious about jumping to conclusions. But they are not reasons to dismiss the anomalies entirely. They are reasons to investigate further. Professor Loeb's position is not that 3i Atlas is definitely artificial. His position is that the anomalies are significant enough to warrant serious investigation. He is advocating for what he calls proportional investigation. The idea that we should devote resources to investigating anomalies in proportion to their statistical significance. If something has a 1 in 10,000 probability of occurring naturally, we should investigate it 10,000 times more thoroughly than something with a 50-50 probability. This is not about proving aliens exist. This is about following the scientific method, about taking anomalous data seriously, about not dismissing possibilities just because they are uncomfortable. The Galileo project, which Loeb founded, is designed to do exactly this, to investigate potential technosignatures with proper scientific rigor, not to prove preconceived conclusions, but to gather data, analyze it objectively, and follow it wherever it leads. The media coverage of 3i Atlas has been mixed. Some outlets have sensationalized it, claiming definitive proof of alien technology. Others have dismissed it entirely, calling it just another comet. Both approaches are wrong. The truth is somewhere in between. 3i Atlas is an anomalous object. It displays behaviors and characteristics that are unusual for natural comets. But we do not have definitive proof that it is artificial. What we have is a collection of anomalies that deserve serious scientific investigation. And that investigation is ongoing. The problem with media coverage is that it tends to be binary. Either it is aliens or it is nothing. Either it is the most important discovery ever, or it is completely boring. But science does not work that way. Science is about gradual accumulation of evidence, about careful analysis, about following the data wherever it leads. And the data on 3i Atlas is still coming in. We are still learning. We are still investigating. So what should we make of the January 7th Hubble image and the triple jet mystery it reveals? Here is what we know with high confidence. 3i Atlas is displaying a triple jet structure with 120-degree symmetry. The dominant anti-tail points sunward across distances of 400,000 kilometers. The rotation axis is aligned within 6 to 8 degrees of the sunward direction, a configuration with 0.2% probability. The trajectory is aligned within 5 degrees of the ecliptic plane, another 0.2% probability event. The compound geometry has probability approaching 1 in 10,000. No radio signals have been detected despite sensitive SETI observations. Multiple aspects of the object's composition and behavior match natural comets, but with unusual characteristics. Here is what we do not know: whether the geometric alignments are coincidental or indicative of underlying physical principles we have not identified, whether the anti-tail is maintained by exotic gas dynamics, unusual ice distribution, or something else entirely, whether continued observation will reveal additional anomalies or resolve the existing ones through natural explanations. What Professor Avi Loeb advocates for, and what this channel supports, is proportional investigation. Anomalies with compound probability of 1 in 10,000 deserve scientific resources proportional to that improbability, not to prove preconceived conclusions, but to understand what we are actually observing. The January 7th Hubble image is the clearest documentation yet of behavior that challenges standard cometary physics. Whether that challenge reveals gaps in our models, unusual but natural phenomena, or something more exotic remains an open question, but it is a question worth asking, worth investigating, worth taking seriously, because the universe is under no obligation to make sense to us on our preferred timescales or through our preferred explanations. It is what it is. Our job is to observe it accurately, analyze it honestly, and follow the data wherever it leads, even when it leads somewhere unexpected. If you found this deep dive into Professor Loeb's research valuable, hit that subscribe button. We are building a community of people who want to understand the cutting edge of astrophysics without hype, without dumbing down, but also without dismissing genuine anomalies just because they are uncomfortable. Drop a comment with your thoughts. Do you think 3I Atlas's anomalies indicate natural processes we do not understand, or something else? What would convince you either way? Share this with anyone interested in serious scientific analysis of interstellar objects, and check the description for links to all the sources. Avi Loeb's Medium articles, NASA's Hubble data releases, the Breakthrough Listen paper, everything cited in this analysis. Stay curious, stay skeptical, stay open to wherever the data leads. I will see you in the next one.